Welcome. It is a pleasure to have you here for this presentation on Enterprise Agentic AI, the 2026 Playbook. As we look toward the near future, the integration of digital labor into our existing ecosystems, specifically Azure DevOps, is becoming a strategic necessity rather than an optional innovation. Our goal today is to provide you with a comprehensive operational strategy and implementation guide. We will focus on how to deploy autonomous agents with the extreme security and precision required for large-scale enterprise environments. By effectively bridging the gap between human intuition and machine efficiency, as represented by the convergence in our opening visual, we can unlock unprecedented levels of productivity. Let us begin our exploration into how you can transform your DevOps practices for the year 2026 and beyond. We are witnessing a fundamental paradigm shift in how we interact with artificial intelligence, moving from treating AI as a mere tool to utilizing it as a form of digital labor. Between 2023 and 2025, AI has primarily functioned as an assistant. Its main focus was code completion, acting as a reactive partner where the primary limitation remained that a human had to initiate every single action. As we look toward 2026, we enter the era of Agentic. In this new phase, the focus shifts to independent planning and execution. AI agents no longer just type syntax, they plan, execute, and verify complex tasks, navigating the entire software development lifecycle independently. However, as we embrace this shift, we must remember the foundational principle. While we can delegate the execution of these tasks to digital labor, we can never delegate the accountability for the outcomes. Phase 1 focuses on establishing the Azure AI Foundation through 4 key architectural components. First, the Model Context Protocol, or MCP, acts as a secure bridge that allows agents to pull context directly from platforms like Jira, GitHub, and Wikis, removing the friction of manual data exports. Second, Entra Agent ID introduces managed, auditable non-human identities, enabling us to differentiate between agent-initiated and human-initiated changes within our audit logs for better governance. Third, managed DevOps pools provide secure, scalable execution environments with localized access to private VNets, ensuring infrastructure integrity. Lastly, knowledge graphs are utilized to map dependencies between microservices, helping agents accurately calculate the blast radius and potential impact of any code changes. In Phase 2, we focus on the rigorous onboarding process for our digital employee, ensuring it is integrated into our ecosystem with the highest standards of security and efficiency. This begins with identity and access management. We establish a unique service account, SVC-AI Agent-Dev, specifically to ensure that personal credentials are never shared. The scope of access is strictly defined. While the agent has read access to repositories and boards, write access is limited exclusively to AI feature branches. To further bolster security, we leverage OpenID Connect for short-lived tokens, minimizing the risk associated with long-term credentials. Moving to operational guardrails, we implement rate limiting to cap API calls and pull requests per hour, preventing any potential flooding of our development pipelines. Financial oversight is maintained through hard budget caps at the LLM provider level, such as OpenAI or Azure. We also utilize context optimization via .ai ignore files to block the agent from processing unnecessary large binaries or legacy folders, keeping its focus on relevant data. Finally, under security basics, we employ automated secret scanning to block pull requests containing strings that resemble API keys. To ensure data privacy, PII scrubbing is applied to cleanse prompt context before any data is transmitted to external LLMs. As shown by the Agent 01 badge, these digital employees are treated as formal entities within the DevOps and AI departments, operating under a robust restricted access framework. Phase 3 focuses on agile integration and ceremonies, introducing specialized AI personas to streamline team workflows and enhance data-driven decision-making. We begin with refinement, where the librarian automatically scans user stories to identify missing acceptance criteria and flag potential architectural dependencies before they impact development. Moving into planning, the estimator leverages historical velocity and cycle time data to suggest highly accurate and realistic story points. During the stand-up phase, the facilitator provides concise summaries of recent activity, such as commits and status changes, to uncover silent blockers that may otherwise go unnoticed. Finally, in the retrospective, the analyst performs sophisticated sentiment analysis on team communications and identifies operational bottlenecks. This integrated cycle ensures that every ceremony is objective, efficient, and focused on continuous improvement. Phase 4 focuses on establishing robust governance and branch policies to safeguard our codebase. We have enabled a policy that prohibits the most recent pusher from approving their own changes. This specifically prevents automated service accounts, like the SVC-A agent, from approving their own pull requests, ensuring mandatory peer review. Furthermore, we are automating reviewer inclusion for critical code paths. Any pull request affecting the src/auth directory will now automatically and mandatorily include the security lead as a reviewer. This ensures specialized oversight for all authentication-related changes. Lastly, we have configured the bypass policies to prioritize security. For the SVC-A agent, the ability to bypass policies is explicitly set to deny. Because an explicit deny always overrides an allow in our permissions model, this ensures that the agent remains subject to all governance controls without any exceptions. Phase 5 focuses on the guardrail pipeline, which serves as our automated pre-flight check, configured via the guardrail.ai.yaml file. This pipeline is automatically triggered during PR creation whenever the isAI agent flag is set to true. The first stage involves deterministic tools. We run standard linting with ESLint and perform static application security testing using GitHub Advanced Security to catch well-defined issues early. In step 2, we transition to non-deterministic tools. Here, the Azure AI Logic Auditor analyzes the linked work item alongside the code diff. This step includes a critical fail condition. If the tool's confidence score is less than 85%, the pipeline will stop. Finally, step 3 acts as our coverage gate. For any code contributed by an AI agent, we mandate a strict 100% test coverage requirement. This comprehensive sequence ensures that AI-driven changes are reliable, secure, and fully verified before they enter the codebase. This slide illustrates the AI Logic Auditor, a sophisticated tool designed to identify logic hallucinations by systematically comparing intent against implementation. The process begins with 2 core inputs, the work item, which outlines the user story and requirements, and the code diff from a pull request. In this specific example, the requirement clearly states that a user should be archived upon deletion. However, the code implementation utilizes a db.remove function, which performs a permanent deletion rather than an archival process. The Azure AI Logic Auditor analyzes these inputs and detects the logic hallucination. Because the code implements a hard delete instead of the required soft archive, the audit result is marked as failed. This failure automatically triggers a block merge action, serving as a critical safeguard that ensures technical execution remains perfectly aligned with business requirements. Phase 6 focuses on solving the black box problem by implementing a structured reasoning path comment template. This approach provides necessary transparency into how an agent arrives at its conclusions. Looking at this example from Agent 01, we start with an executive summary that clearly defines the intent, refactoring the payment processor for multi-currency, alongside a 94% confidence rating. The decision tree then breaks down specific architectural choices, such as using immutable map to prevent side effects and decimal.js to avoid floating point errors. We also include an assumptions section to flag dependencies, like the reliance on real-time data from an exchange rate API. The primary benefit of this structured output is that it shifts the reviewer's focus from basic syntax checking to critical logic verification, ensuring a much deeper and more effective level of human oversight. The transition from human-centric development to AI-driven workflows necessitates a fundamental rethinking of our definition of done. This comparison highlights the rigorous standards applied to AI agents across 4 critical pillars: testing, documentation, security, and verification. Starting with testing standards, while 80% code coverage is often the accepted baseline for human developers, we require 100% coverage from AI agents. This must include exhaustive boundary analysis and negative test cases to ensure every logic path generated by the model is fully validated. In terms of documentation, we move beyond standard inline code comments. For AI agents, a reasoning path summary and a prompt transparency link are required. These provide essential context regarding the model's logic and the specific prompts that influence the output, ensuring the code remains maintainable and understandable. Security protocols also become significantly more proactive. Instead of relying on periodic automated scans, AI-generated code is subjected to real-time, per-commit SAST and secret scans. This ensures that potential vulnerabilities or leaked credentials are caught immediately before they can be integrated. Finally, for verification, we evolve from a traditional peer review process to a comprehensive logic sanity check. This is coupled with traceable approval, where every contribution from an agent requires a human signature for accountability. By establishing these higher bars for AI, we maintain the integrity and reliability of our systems as automation scales. The human-in-the-loop verification chain is a robust framework designed to ensure safety and accountability when deploying AI agents. At the top of this hierarchy sits the governor, typically an architect or CIO. Their primary responsibility is to verify permissions and maintain strict architectural alignment, preventing the agent from compromising quality by taking the path of least resistance. Moving down the chain, we have two critical technical roles. The reviewer, acting as a senior developer, performs deep code analysis to verify logic and security. A key part of their function is to meticulously check for hallucinated libraries that an AI might erroneously suggest. Simultaneously, the validator, representing QA and security, utilizes automated guardrail agents to monitor performance, yet they maintain the ultimate authority by providing the final human sign-off before any production deployment. Underpinning this entire system is the identity rule. This foundational principle dictates that if an agent causes a production failure, the system logs must provide an immutable record showing exactly which human authorized that specific execution. This ensures that while we leverage the power of AI, human accountability remains absolute. Looking ahead to 2026, we see a landscape shaped by both unprecedented efficiency and new operational challenges. On the side of gains, we anticipate dramatic timeline compression, where tasks traditionally requiring a full 2-week sprint are completed within 48 hours. We also expect structural improvements, such as dynamic documentation, where wikis and readmes are updated automatically, and the achievement of 100% automated traceability, ensuring every work item is perfectly linked to its corresponding code. However, these advancements introduce significant risks. We may fall into a productivity trap by generating code at a pace that exceeds human review capacity. This inevitably leads to review fatigue, as the primary bottleneck in the software lifecycle shifts from authoring to reviewing. Consequently, we must prepare for a major skill set shift, as junior developers are required to evolve rapidly into high-level product and code reviewers. As we look ahead to 2026, the central principle for successful AI integration is clear. Velocity is nothing without verifiability. While speed of delivery remains critical, it must be matched by the ability to audit and validate every action taken within our systems. First, we must redefine how we view AI agents. They are no longer just tools. They are a form of digital labor. This shift requires treating them with the same level of identity management and governance we apply to human personnel. Second, we adopt a trust but verify posture. By implementing technical guardrails, such as a guardrail.yaml configuration, we can systematically catch intent drift before it leads to architectural or security failures. Third, the human role is evolving. Our value is shifting from the manual effort of writing syntax to the high-level validation of architectural logic. Humans remain the ultimate arbiters of intent and integrity. Finally, your immediate call to action is to audit your branch policies. You must ensure that no identity, whether human or digital, possesses zero bypass privileges. Every change must be verifiable and subject to the established governance process. That brings us to the end of our discussion. For more comprehensive details regarding the 2026 DevOps Playbook, please direct your inquiries to the email address shown on the screen. Thank you for your time and attention.